Alright, in lesson 8.5 we're going to use law of sines. So far everything we've talked about has in trig has been using a right triangle. So in the next two lessons we're going to look at how we're going to find missing side lengths and angle measures of triangles that are not right triangles. So there's a couple conditions that will apply here in order to use law of sines. So if we know the measures of two angles and the length of the side opposite one of those angles, which is angle side, or two side lengths and the measure of an angle opposite one of those sides, side angle, then you can find all the other measures of the triangle, which means basically if you have an angle measure and you know the side across from it, then you can use the law of sines. So let's look at this picture here. The law of sines is the ratio of the sine of the angle A over the side across from it, which is side A. And it's equal to the sine of angle B over side B, equal to the sine of angle C over side C. One thing here, notice is all the angle measures are capital letters, all the lowercase letters represent side lengths. These are all doing across. There's no hypotenuse in this because there's no right angle. So across from angle A would be side A. Across from angle B would be side B over here, and across from angle C would be side C. Now when you're working with proportions, as you remember we've learned, you only compare two ratios at a time. So you may be using sine A over little a is equal to sine C over little c. Or maybe sine B over little b equals sine C over little c. So you're only going to be comparing two at a time. So let's look to see how that works. We have two angle measures here. We have 37 and 68. And it says find the measure of side B. Well, if we look here, we know two angles. We know that this is 68. So we're going to be using the equation that says the sine of 68 over the side across, which is B, is equal to the sine of 37 over 3. Alright, so let's, as we set up our ratio, we're going to be using the sine of B over side B equal to the sine of angle A over side A. So let's plug our numbers in. In every ratio, you're going to have one complete ratio. In this case, it's going to be the one with A, because we know angle A and we know side across from it. So we have sine of B, well, B is 68 degrees over side B, equal to the sine of 37 over 3. Now, we're going to cross multiply like we've done before in proportion. So we have B times the sine of 37 equal to 3 times the sine of 68. So next we're going to divide by the sine of 37, divide by the sine of 37, which means that B is equal to 3 times the sine of 68 over the sine of 37. So how do we put this in our calculator? Well, let's take a look. We're going to take 3 sine 68. Now if you decide to put this all on your calculator at once, make sure you have all your parentheses set up correctly. So then I'm going to say divided by the sine of 37. Hit enter and you get 4.62, and it doesn't tell us what to round to, so we're going to round to the nearest tenth here, and that's going to give us that B is equal to 4.6. Okay, so let's go to the next one. In triangle ABC, measure of angle A is equal to 48, the measure of angle B is equal to 93, and the measure of AC is equal to 15. To the nearest tenth, what is the length of BC? Now, because we don't have a picture here, the first thing we need to do is we need to draw a picture that represents triangle ABC. It doesn't matter what it looks like. So let me go back and change that color. A little easier to see. So I got 3 sides, and I'm going to label it A, B, and C. So angle A is 48, so we'll put that in here. Angles go on the inside, segments go on the outside. So angle B is 93, and AC is 15. Now what it says is find the length of BC. So we have our ratio that is, we have a complete ratio because we have the angle and the side across. So we're looking for side A or side BC. So we're going to take the sine of 93 over the side across from it, which is 15, equal to the sine of 48 over the side across, which is A. Cross multiply. A sine 93 equal to 15 sine 48. Divide by the sine of 93. So A is equal to 15 sine of 48 divided by the sine of 93. So now we'll plug that in our calculator. 15 sine 48, close parentheses. Make sure you close parentheses. If you don't, it'll divide 48 by the sine of 93. So we want to do 15 times the sine of 48 divided by sine 93. So now we hit divided by sine 93. Close that parentheses. Hit enter, and we get 11.16. So to the nearest tenth, this is going to be 11.2. So A is approximately 11.2. All right, so next part says, what is the length of AB to the nearest tenth? Well, AB is side C, but we don't know angle C. But we do have 2 angles of a triangle. To find the third, we add them up, subtract it from 180. So we'll take 180 minus the sum of 48 plus 93. Now, once we add these two together, we're going to get 180 minus the sum of 48 plus 93. That is going to give us 39 degrees. So a total of 39 degrees here. So when we set up our proportion here, that means that this right here is 39. So we have the sine of 39 over side C. Now we're going to pick the one that we were given, so we're going to go back to the one ratio that we're given, which is going to be the sine of 93 over 15. You always want to use as much given information as possible. That just ensures that you don't have any rounding errors. So we take C times the sine of 93 equals 15 sine of 39. Divided by sine of 93. Now, we've got C is equal to 15 sine 39 divided by sine 93. So, plug this in the calculator. 15 sine 39, close parentheses, divided by sine 93. That gives us 9.45, which means it's going to be approximately 9.5. All right, so let's take a look at example 2A now. Now, in example 2A, we've been given 2 sides at an angle. The angle, most important thing is to know that we have an angle measure and the side across from that. So, we're asked to find the length of S, measure of angle S, and we've been given the side length 11 across from it. So we're going to take the given ratio, the completed ratio, which is going to be the sine of 120, over the side across, which is 18, because these two go together, is equal to the sine of s over the side across, which is 11. Now remember, anytime we're looking for an angle measure, we're going to be using the inverse function. So we start by cross multiplying. We get 18 sine of s is equal to 11 sine of 120 divided by 18. Now, because we're looking for the inverse function, s is equal to inverse sine of 11 sine 120 over 18. So you can do this a couple different ways as you put it in the calculator. You can try to put everything in at once. Just be careful when you're closing your parentheses. So I'm going to do this both ways in the calculator. You can do second sine, that brings the inverse sine of 11 sine 120, close parentheses, divided by 18, close parentheses. And so that gives us 31.95. And round to the nearest tenth, that would be 30. The 5 is going to round the 9 up to 32. And the to 10, the 9 rounds up this to 32. So s is going to equal 32 degrees. Now the other way to do this is to take 11 sine 120 divided by 18, get this decimal, and then do the inverse sine and do a memory recall or answer recall and hit enter, and this gives us the same number as we had before, 31.95, which is going to round to 32. So we have this in is 32 degrees. All right, now let's look at the next one, part 2b. First, start by drawing the picture, then find the measure to the nearest tenth of angle K. So you work this one by yourself. Pause the video and come back to it when you're done. All right, so let's make sure we're working it correctly here. We have our triangle labeled KLM. KM is 14, angle L is 105, and LM is 9. So we have one complete ratio. We have the sine of 105 over 14 equals the sine of K over 9. So we'll first start by cross multiplying. 14 sine of K is equal to 9 sine of 105. Get rid of the 14. So this gives us that K is equal to inverse sine of 9 sine 105 divided by 14. So let's plug that in our calculator. Clear this previous one off. So we're going to do inverse sine of 9 sine 105, close parentheses, divided by 14, close parentheses again. That gives us 38.38, so the nearest tenth is going to make this 38.4. So K is approximately 38.4 degrees. All right. So this concludes the first two examples in lesson 8.5. Next lesson we'll have the next two examples.